Ashish, and good morning to all the gurus, and welcome to this Setu 2025 program. The topic of today's discussion is the search of life beyond the earth. I know that you have already gone to various lectures from eminent scientists of ISRO, uh, and you have seen that how ISRO different programs are being conducted and what are the future programs of ISRO. The topic of searching life beyond Earth is very important, as we always think from our childhood, and particularly students are very much eager to know that are we alone in the universe, or we have some other form of life or similar life beyond the Earth. That question remains important to us, as well as most of the space agencies conduct their experimentation and planning to do various missions to look out for life beyond the earth. So today we'll be discussing about the basics of what is the life beyond the earth, what are the techniques, what are the missions being conducted in this particular line. So let us start with the background that life first emerged on Earth more than 3.8 billion years ago. Although we are doing planetary explorations over 6 decades, and we have covered most of the planetary system, at least in solar system, but we are yet to see a concrete evidence of life form. Although we have seen many places, their conducive nature or something which that light can be there, but finding continues to be our quest. And what we see during our investigation is that principle of physics and chemistry are universal. These planetary bodies, they revolve in certain fashion. We have a knowledge about it. They have certain chemistry of atmosphere, the chemistry of the what you call soils or their surface property, and the fundamentals, the principles are very similar. What we have on Earth also, but then the question comes that why biology is specific to planet Earth? Why we have not found a life form kind of thing in other planets? So what dictates it? And what are the ways people are working on this line to do so? So if you see, by now more than 5,000 exoplanets has been discovered. Exoplanets are the planets which are there in other star system and have a likelihood of habitability there. So one study was published this year only in Scientific American, where they tried to see the demography, how they are distributed, these thousands of exoplanets, in terms of their sizes with respect to Earth radii and orbital period. And when it was plotted, so y-axis is orbital period, the days it requires to revolve, and x-axis is a planet radius, how big it is. So we find the solar system, these planets, they lie in one part of this scattergram. There is an upper portion. Majority of time, our orbital period is larger. Although by now discovered exoplanets has various sizes. They vary from the Earth, Mars, to even they go to the level of Uranus, Neptune, but the orbital period are not the similar what we have. So it says that the kind of dynamics we have in solar system is not very unique. World or the universe is made up of various other processes, so we are not that unique in the system. So we have to know more and more in that line. So question come, what is the planetary habitability? How do we say that life will exist or not, and what are the conditions? That is the basic question anybody would like to know. So planetary habitability is the measure of planet or natural satellite potential to sustain life. So does a planet have potential to do that? So how do you know this potential? So it is basically an extrapolation of conditions on Earth and the characteristic of Sun and the solar system which appear favorable to life. So essentially, we think that whatever is favorable on the Earth would also be favorable there. Like if a planet is very close to its sun, what will happen? It will become too warm, like Mercury, and there would not be a chance that life can emerge in such a hot system. If planet is too far away, like Jupiter or Saturn, they will be too cold. They would be icy, and then the chance of becoming the life also becomes poorer because light also of the star sun will not reach much there as the distance is far off, and hence since life required life as what we think our life is based upon the light, the sun, so the life would not be there. So there is a habitable zone, a virtual region where we think, depending upon a distance of the planet with respect to a sun. Sun can be bigger, sun can be smaller. Looking at the condition, there will be a zone where it will be habitable. Means there will be enough light, enough environmental condition, temperature, pressure, and there would be availability of water, so that becomes habitable. So ultimately, what defines this habitability? So as I said, solar characteristic. What type of our star is? Okay, luminosity, the solar variations, and other things, and planet property like masses. Is it bigger or smaller? If it is smaller, it will not able to hold the atmosphere like moon. Moon lies very near to Earth, but being smaller, it is vacuum. Its atmosphere has gone back. So mass is important, the size is important, orbit is important, geochemistry, microenvironment. So many things are equal. That is why to have a planet a life, you have to have many characteristics of that. Okay, let's learn from the evolution of life on Earth. So we can get some clues what would be the type of life in other planets. So we all know that on Earth also, life started sometime later. It didn't happen at the birth of the Earth itself. And what happened? It is started by bacteria. Bacteria holds more genetic diversity and account for more biomass than plant and animal. Do you know? The bacteria are the basics, fundamentals, and they came first, and they remained there. And then came archaea, eukaryotes, plant, then fungi, then later on the fishes, amphibians, reptiles, birds, and mammal came in the very late part of it. This is how the evolution took place. In between, many mass extinction also took place. We all know in our school studies. So humans are rather recent occurrence, only 6 million years ago in the history of 3.8 billion years. So, before we understand the possibility of life, we have to define life itself. What is life? So, life is a self-sustaining process which undergo metabolism, growth, reproduction, and adapt to the environment in successive generation. If this kind of what you call properties are there, then only we will call a system having a life. And diversity of life is a real result of dynamic interplay between genetic opportunity, metabolic capability, environmental challenge, symbiosis. To life to exist and diversify, there are many other characteristics of ecosystems are required. Most important is energy. We all know without energy nothing works. And most of the time energy is sunlight. But remember, it can be chemical energy too, because in the bottom of ocean there's no sunlight, still life forms. So it has to be energy. It could be of thermal, chemical nature. Environment, of course, water, nutrient, temperature, atmosphere. That is the basic governance of this life. So any planet having this kind of adequate optimal environment only can have life. And even on Earth also, the life diversity is a function of all these things. That is why you do not see in some places where there is no adequate environment, life do not exist there in many of the places, even Earth itself. And most important is radiation protection. Protection is most important. Even if I have energy, even if I have environment, but I am not protected, like my UV radiations come, there's no protecting layer on the top ozone layer. Everything would destroy. Suppose solar flare comes to the Earth and there's no magnetic field available to us, which can stop the solar flare to impact on the Earth. How the life will? So the life on Earth also exists because there are protection given by various things like UV, magnetic fluxes, and many other such kind of things. So, what are the basic form of energy? Photosynthesis, we all know. Photosynthesis is a form of energy when we get from our sun or the star light. Chemosynthesis, I said, it can be there. That is why I said there are many hydrothermal vents on the bottom of ocean where there is no photosynthesis, still life exists. And there is a question. Since we think life exists in form of carbon and water, no? Because ultimately we have seen this form. But is it necessary that all the planet should have a carbon and water basis only? People think not necessarily. Not necessarily. It can be some other basis. Some people think that silicon based system can also be there. Although it is a research, but yeah, the question always comes: why only carbon should form the life basic ingredient? So we don't know. While further exploration in various space environment, there are notions that few more molecules can form the basis of molecular basis. Let's quickly go to photosynthesis. It is taught in our school time frame in 11th, 12th biology that when carbon dioxide and water mix up together in presence of sunlight and chlorophyll, of course, you need chlorophyll for them, they create sugar, C6H12O6, and oxygen. This is a very fundamental process when carbon dioxide in presence of sunlight and chlorophyll creates sugar and oxygen. And that forms the basic fundamental of life on Earth. So, sunlight is essential. And do you know when it started? It started nearly 3.4 billion years ago, when the first bacteria started using the sunlight to create this biomass or this organic component. There will be many planets where light exists, but still, if bacteria are that form of photosynthetic bacteria, cyanobacteria is not there, it will not be converted into organic matter. So this is a fundamental principle. Recently, I was reading that Matasuo et al. Has written that early ocean were iron-rich and green. How does this green color came on the Earth? Majority of them. One clue I would say, the peak light wavelength is green. If you see the curve of solar light, no, the green color is the maximum intensity you get in sun, because that is basic characteristic. So one can say it is most preferred. There is another hypothesis I found that hydrothermal vents erupting across ocean floor pumped reduced iron Fe2 into the water, filling the sea with ferrous iron. This green light environment had significant consequence for the organism living into it, like cyanobacteria. The early masters of photosynthesis began to adopt. So it could have happened like that the ferrous iron, which was a relative bit of green color, would have bacteria would have adapted to greenness, and later on this photosynthesis process would have happened in the green aspect of life. That is, our plants are green because in that you get more light to create organisms. So there are many evolving theories regarding that. Of course, later on this green color becomes blue because more transformation of this ferrous iron when they interact with atmospheric oxygen, becomes spheric, and they dissolved in the water, and then the water started changing its color. So the beautiful theory says that early oceans were iron rich and green. Will all the what you call planet will look green? Not necessarily. They may look red. Just I'm showing you the what you call a picture, simulated picture of any other planet. Why? As I said, one logic is that suppose star type G is there. Stars have various types are there, with depending on their temperature. Like G is like our sun, which has 6,000 Kelvin. But there are F, there are K. F is 7,500 Kelvin. K is 5,000 Kelvin. So for the G type, uh, the peak emission happens in 583 nanometer, which is green color. So we see majority of time we are green. There's one linkage out of it. Suppose star is F type, mass is 1.4 times of our sun. So what will happen? If the what you call temperature is high, according to Wien displacement law, the peak emission wavelength will shift and it will become lower wavelength. This principle is called Wien displacement law. So what will happen? Its peak emission will start coming at 451, which is a blue kind of light. So that particular star might have a bluish kind of planet where most of the things are bluish, or temperature is low, so peak emission can shift to red, because ultimately it is temperature of a star which gives its peak emission. So depending on star and the color, I mean the temperature, I mean it is hypothesized that different kind of colors, dominant color I would say, may come up in a planet. So next question comes, anyway, how do I know this? How do I say that so many stars are there, exoplanets are there, and they are habitable? So the Kepler mission in 2009 discovered most of the Earth-like planet. This particular mission by now has discovered 5,638 confirmed exoplanet. And every year you'll find some new discoveries coming up, and we'll discuss how it does so. So it does through a principle of transit method of detecting extrasolar planet. What is this transit method? When a planet crosses in front of a star, as viewed by an observer, event is called transit, and transit by a terrestrial planet produces a small change in star brightness. It is very, very small, 1 upon 10,000 even. So, if you detect them, it means that particular star has a planet, because whatever the light was coming from a star, suddenly we got a dip in light. And this method, when they use focus different star, they are able to know the what you call exoplanets in that particular star. Recently, the famous telescope James Webb is also used similar principle, and they are also detecting the exoplanets through this transit method. In this particular curve, you can see there was star relative brightness. Suddenly, when the planet of that particular sun or the star obstructed the light, we saw a dip in light, and that's how where you start knowing, oh, it has a planet, and it might be habitable depending upon its distance from the particular star. A similar principle is also there, that is called radial velocity. And in this you do not do the you do not see the change in light, but what you do, you focus a star. If star has a some planet, obviously this planet's mass will influence the star in terms of gravity attractions, and it will make planet wobble. So the star wobble. And if you start seeing it and start seeing it radial velocity, you will see it will change, and the change is a function of a accompanying planet in the star. What people do, this is also called what you call a wobbling Doppler effect. The star start wobbling due to influence of the exoplanet, which is revolving, and one starts seeing the shift in the emission. It can be blue shift, it can be red shift. And looking at that, we are able to know that this particular star has a revolving exoplanet. Now, depending upon the size and the orbital period, one can know whether it is habitable or not. So one of the unit which we are going to listen from the director of that unit, Physical Research Laboratory, they have discovered a exoplanet using advanced radial velocity method. That instrument is called PRL, Advanced Radial Velocity Abu Sky Research PARAS spectrograph, and it works in the Mount Abu, and they have detected one exoplanet. Mass is around 27 Earth mass and size of 6 Earth radii. It is around 600 light years away from the Earth. So ISRO is also working in this field, and PRL is continuously working through PARAS to look out various exoplanets. Question comes, I saw the exoplanet. Okay, I saw it either through transit method or through radial velocity or Doppler wobbling, whatever you call it. How do I know it is habitable or not? So one is that anyway, you compute the distance and from the star, and we know certain distance would be habitable and some would be not because it will be too hot or too cold. Second approach is spectroscopy. You also put spectrometer which split the light into different small components of wavelength in a different wavelength region, and since a star or a planet which has atmosphere will have a different composition of gases, and in school we know in school physics that every molecule has certain absorption feature specific to their molecular structure. So when we see through spectrometer, we see dips or absorption by that particular atmospheric composition at different wavelength, and since we know that methane, oxygen, water, whatever it is, it will have certain absorption in that wavelength. By detecting that absorption, we are able to tell the composition of the atmosphere of that particular star or the planet itself. Here what we are seeing is one of the atmospheric composition of Mars. It has been detected by the James Webb. You can see since Mars has majority of carbon dioxide and some bit of water molecule, carbon monoxide, a bit of it. All these absorptions you are able to see them because they have the relative dips into the brightness of light at different wavelengths. And physicists know that what are the wavelength, which molecule will have a absorption. This is a molecular spectroscopy. These principles are used. In fact, if you see our Earth from a distance, people have tried to see that in different wavelength region, like visible on top, you can see second curve, so the mid infrared, and then third curve shows thermal infrared, and you can see what you call different absorption dips and ups, and they're all because Earth has these molecules of O3, O2, H2O, CO2. So if any alien would look us from a very distance, he will see this kind of spectra. So by seeing similar spectra in other planets, we will able to say that that particular planet has this particular molecules in their atmosphere. One way of dealing this particular what you call planet or the search of life beyond this is called search of extraterrestrial intelligence, SETI. Here what they do, they use radio telescopes. and from that radio telescope, they find the signals. Way of discovering extraterrestrial civilization to detect artificial radio emission from location outside the solar system. This is another way of detecting what you call life in the other solar system. Now let's come quickly in 5 to 10 minutes. We'll see that okay, apart from going to the another what you call solar system or other star system, if we have to find life within our system, solar system, where do we find out? Because going other planets would be difficult. Even if you find, how do you reach there? It will take huge amount of time. So idea is that we have to find some conducive life system in our solar system. So if at all we have to find out where are those systems available, in which planets, or which satellites of some planets we can see. So I would talk about the major five one. First, anyway, the most preferred is Mars, because we have already gone to Mars. Even India, has gone to Mars through its rocket called Mars Orbiter Mission. In 2013, it was launched. It reached there 2014, 24 September. So it is reachable. And there is a high chance that there would be a life in some other form. And that's why many further explorations are going on. India also has a plan again to go. Maybe the next time it will be rover or lander. Io, Jupiter's moon, also is one of the, I would say, very important place where there is chance of life happening there. Europa, Jupiter's moon, is another important. So Jupiter has two moon, Io and Europa, where there is a likelihood of finding life there in some form. Titan, Saturn's moon, is also one of the important, and it has been very long talked that Titan is very similar like Earth, so there is chance that there would be life. And another one is Enceladus. It is another Saturn moon. So one is Mars, two moons of Jupiter, Io and Europa, and two moons of Saturn. There is a possibility. Of course, there can be many more. So we'll discuss 4, 5 this thing. Why we think there is a possibility. We all by now know that our own mission, Mars Orbiter mission, did a lot of good experimentation. It had 5 cameras, and I was fortunate to be the PI of one of the camera called thermal infrared imaging spectrometer. It has Mars color camera and many more. So when we analyze various images, particularly I am showing you Mars color camera, you start seeing the flows of water there. There are many signals. So we computed how much water would have been there. So this particular image shows you that you see the origin of water is a linear line you are seeing. So it is a geological origin. It is not that there was a Himalaya and from there melt will come. It was a geological tectonic movement which brought the water beneath the surface and started flowing in a Mangala Valley. This valley is named as a Mangal Valley. So, like that, there are many places where you'll find the traces of those water kind of flow there. This is one study we did together, and many places you'll feel like a flowing kind of structure. It's called recurring slow linear RSL. Still, people are working on that line. Is it really a water kind of thing or what? It's not very much confirmed by now, because water cannot remain there on surface because the pressure being very low. To water to exist in the form of liquid, there is a certain temperature and pressure. Temperatures are very similar like Earth in a colder region we have in Mars, but pressure is very little because atmosphere has been mostly escaped and is a thin atmosphere. The chance is very little, but then people think if it is a brine water, there is a likelihood that that condition can exist. So work is going on the direction. This picture anyway shows one of the ESA's Mars Express orbiter that whenever there was an impact and crater was created, beneath you see the flowing pattern. How this pattern can come? It is because the effect of heat produced powerful smash and melted the soil. So beneath the soil, there is a chance, there is a high probability that there is a liquid water available there. But once it is heated with this kind of phenomena, they may come out. And that gives a huge, what you call, attraction that why we should explore. There is chance that subsurface processes are there. And that's why many missions are aiming to do that. One particular experiment was done by Mars Express itself. It has a radar which can penetrate the surface, and it can go. It can go subsurface, and there they found bright radar echoes, which can only happen when you have a liquid kind of water there. So these observations also suggest in some southern pole that beneath surface water is there, and if there is a water, obviously there is a likelihood that some form of life may exist. So these are the few clues I would say exist, and that's why many space agencies are aiming to go there and probe further more and more. There is another evidence that people found a methane emission happening there, taking place. They detected from the Curiosity rover. Although amount is not very high, but looking at the seasonality, it changes from summer to autumn. What you call there is a hypothesis that it can be due to biogenic origin. Although it does not prove a methane being there does not necessarily mean life would be there, because it can have a geological origin. But since people found a seasonal cycle into it, and seasonality many times is linked to the biological activity. So that angle also has to be further probed through more sophisticated rover and lander. So I was talking about, let's go to Jupiter first, Io and Europa, and see that whether life would be there or not, and why a life should be there. I was telling earlier you that they are far away from sun, so obviously sunlight is less, so they are more of a icy, but still they do not come in so-called habitable zone, because they have the distance being far away, 10 AU as compared to what Earth is. But then people also found they have hydrothermal vents. Beneath the surface, there are many processes going on. People saw plumes, people saw liquid methane, cryo geysers, cryovolcano, subsurface liquid water, tidal flexing, radioactive heating. There is chance that some heating, some energy source is also there. So it is not always the sun energy, it can be of another form. And that makes some interesting that these planets, these moons of this particular planets have life. So if you talk about Io, which is the moon of Jupiter, people have found dense active volcanoes and plume of sulfur and SO2. That has been seen through various spacecraft while flying from there. So that gives one particular clue that there would be their dynamics. So it need to be further explored. Europa is most preferred one, and one of the Jupiter's 4 Galenian moon is there, this Europa, and is the 6th largest moon in the solar system. It's thought to have a water ocean beneath the surface, and like Earth, an internal energy source from radioactive decay. So this has led to hypothesis that life may exist in conditions similar to that of Earth. That is why you will find that NASA has sent a mission called Europa Clipper. It is already on the way, and they want to know subsurface things. So they are using many instruments are there, but one radar is there at 2 frequencies, 60 megahertz and 9 megahertz. It has a capability to penetrate. So once it reaches there, you will find that more clues will come about the life in Europa. So already NASA's Europa Clipper mission is on the way. Titan, as we're talking about, is very similar like Earth in size, and people find dense atmosphere, liquid surface, because it is similar like Earth. So atmosphere exists, liquid surface, and ammonia-rich liquid water subsurface. So says that methane was found in liquid form in methane sea in Titan's North Pole. So people think that it can give some form of life there, can be conducive to that kind of situation. And see, let us, I am coming again to Saturn's another moon. It is fresh and clean ice is available. Plume of water is seen. Subsurface liquid water possibilities are there. Otherwise, why so much plumes will come out from that? To multiple jet dominated by water vapor ice particle containing rich mixture of other compound emanate from active warm fractures at Ancil at the South Pole. Cassini has seen it. So that gives a, what do you call, promise that there will be much, what do you call, there are many surprises lying there, at least within the surface. So I just covered in general that how to find life in different planets, how to define life, on what it depends, and what are the methods, and what are the potential places in solar system where we should go and to call look for the life. So, and in future, what are the way ahead? Our solar system once thought a blueprint of all planetary system. Now it stands as just of the countless possibility. It is not that everything has to evolve like solar system. Things has evolved differently in terms of their sizes, orbital period, and everything. Anyway, ISRO's unit PRL is continuously working on this field using PARAS, and many more programs are being worked out to see, have a better and better what you call spectrometers and telescopes to look, hunt exoplanets. NASA transiting exoplanet survey satellite missions is there. European Southern Observatory extremely large telescopes are working at that line, and NASA's Habitable World Observatory also aims to do similar kind of research. So in future, as human curiosity continues to be there, many experiments would be conducted, many exciting findings are awaited. So it was our what you call it was my thinking that you all gurus who are teaching a student, I mean, should convey this feeling that whatever read in our school time, the physics, chemistry, mathematics, biology, whatever fields we are studying, their fundamentals are very much required, and they form the basis of many new experiments and many missions. They are the fundamental blocks of our knowledge, which later on help us to design new experiments. Thank you very much.